Welcome everyone. Today we have our another new episode and we will discuss on the nano dimension. We will discuss on nanotechnology. We have our world famous speaker, Professor David Smith and Mr. James Sid. Mr. David Smith, what you want to discuss about the nano dimensions or nanotechnology?
Well, Dr. Shreve, thank you so much. There's a lot to talk about on nanotechnology, and that's almost funny because nanotechnology is so small. And nanotechnology is a field that it goes into the manipulation of matter at the nanoscale, where dimensions range from about 1 to 100 nanometers. Uh, and at this scale, it's really hard to predict what's going to happen. There's some unique things that happen at that scale because you're beginning to get into quantum mechanics. You're beginning to get into physics that is very advanced and very not understood well right now. Uh, but the definitions here are really important because it involves the not only understanding, but it's controlling matter at that scale. It's research, it's technologies dealing with the special properties there. Uh, Scientists actually use the form nanotechnologies or nanoscale technologies to refer to this because it's such a broad range of science, such a broad range of search, and such a broad range of applications where it can be applied to. Um, this is not a science, a technology that goes back for a long time in history. It was first mentioned back in 1959 by Richard Freeman in his talk. Is there plenty of room at the bottom? And you see that there. And uh, he envisioned manipulation of atoms and molecules for doing microscale products, which today is known as molecular nanotechnology. And like I said, it spans such a diverse field of places because you have to have organic chemistry, you have to have physics, you have to have molecular biology, you have to have mechanical engineering, you have to have surface science, semiconductors, energy storage, micro fabrication, all different types of engineering. And then you have to look at uh, how can I put these into products? And this is a place where regulation is just now beginning to say, how do we regulate this? How do we protect the life and safety of people around it? Uh, and how do we begin to set that in a way that is makes sense? And uh, it's a wild west in that side of the regulations around it. So what are some of the applications? There's many different ones, but some of the leading ones today are things like nanomedicine. Uh, you know, uh, it promises breakthroughs in healthcare. It lets us enable targeted drug delivery, going in situ, going into the body to deliver these drugs wrapped in nanomaterials. Diagnosis, it's being used there. It's being used for personalized treatments. You go to nanoelectronics, and this is smaller, more efficient electrical components that can really revolutionize computing, communications. Some of these nanomaterials are helping us extend Moore's law, which is looking at increasing the computational capability of chips, lowering the power, lowering the heat, which have all been challenges in there. Biomaterials. These are material enhanced properties that, for example, with strengths and flexibility, we're seeing biomaterials being used in many industries. We're seeing it being used in space. We're seeing it be used in aerospace. We're seeing it used in construction. We're beginning to see it used more and more in manufacturing. And we're even beginning to see uh, biomaterials beginning to use in clothing, in retail, energy production, nanomaterials, and nanotechnology really contribute more to the beginning to build more efficient solar cells, more energy storage, and like I said, we're even seeing it used. Materials really help us build stain-resistant fabrics to scratch resistance coating that can be used. Well, there's those, but like I said earlier, there's um, still some downside. There's still some challenges. And some of these is what's the environmental impact? What's the toxicity? What's the safety of this? And the safety of these nanomaterials is a critical consideration that is not well understood right now. What is the economic effects? Uh, it takes some advanced facilities and things to develop nanomaterials and to translate them into products. And what is the impact of this going to be on a global economics, particularly as I look at the equality of it being used globally? And what is the regulatory side? There's discussion from being very optimistic about the technology to very doomsday type of scenarios. And what we're seeing is there's all types of advocacy groups on both sides of the coin that are approaching governments to consider special regulations around nanomaterials and really to go back and help us understand that the nano dimension is something that, as you phrased it in the intro, Sharif, that is there, but we don't understand all elements here. And it's one that has promise. It's one that has considerable risk. Uh, and I fortunately have seen some of the early stages of it when Smiley was at Rice trying to build a nanomaterial buckyballs and using it to build a ladder to space, among other things. So, there's that grandiosity type of design in it too. To, gee, can I use nanomaterials in my shirt so when I drop something on it at dinner, it doesn't stain? So it's a wide range of things. Nanomaterials that can flow through my blood vessels and deliver medicine. Uh, so again, wide opportunity, but it really has not been well understood in the risk and the ethics and how to regulate it. So, Sharif, I think that's my opening remarks.
Thank you, Mr. James. What you want to discuss about nanotechnology and how does it different from traditional manufacturing method?
No, thank you, Sharif, for the opportunity, and thank you, David, for a wonderful setup. That is very, very well done on your part, both citing the possibilities and the risk. And the nano, it's hard to wrap your mind about what we're talking about, the nano dimension. A nanometer is a billionth of a meter. It's very difficult to project yourself into that kind of uh, place. And to imagine that kind of work. But it's being done. We have the technology now to manipulate atoms, to manipulate things on a molecular level, and to be producing things, manufacturing things at that level. And we've also introduced AI into the equation. So there can be some adaptation, self-learning during the manufacturing process, so it can become more efficient. One of the things that is the risk, as David mentioned, we are using it now in materials that we do use, in coating especially. There's been some documentation of fiber nanotechnology, nanofibers, excuse me, getting into your lungs and causing cancer. There's been some documentation of that we use it in socks, for example, and you put them into the wash, and they get into our water systems, and the nanofibers interact with the bacteria in our sewage treatment plants, and it's something to be concerned of. But the promise outweighs the risks, and we're not going to put the genie back into the bottle. But the one of the things that is happening is that you can connect at a nano level and share this manufacturing technology. And as David said, it's cross-disciplinary. And you can share it locally in a lab and globally as well. So the potential for cooperation around the world in manufacturing and cooperation is the key here, rather than competition in each individual country trying to do its own thing. And but the idea of regulation is also very important. And there's only one city, and I guess we can imagine which city it is. It's Berkeley, California, that has passed regulations. And Cambridge in Massachusetts thought about it, but decided not to regulate. So how we're going to regulate this advancement, and what kind of oversight is there going to be to protect the public is open to question. As David said, it's the Wild West right now. So we have this pattern of making an advance, causing harm, litigation follows, and then regulation. And usually by that time, over the course of years, the litigation and such, the regulations no longer apply to what's currently going on. So we're in this cycle, and can we get ahead of it and do the advanced regulations, which means people that have to understand this. And there are few and far between that understand this, and not that anyone does, but that have enough understanding to make sensible regulations to govern the manufacturing process. Can we achieve that? We've never done it before. I'm not optimistic that we can, but that has to be one of the goals, is before we do harm with these products, we can hopefully create a system that allows all of this marvelous, wonderful technology to be developed. And I also think medicine going to be one of the key components of this nanotechnology, because right now we can all imagine the COVID protein with its spike so that it can penetrate cells. We can imagine that it happening, but the treatment for that would be at the molecular level. It would be it would be injected into cells to protect the cells from that spike protein. That's just one example. When we talk about the cancer cells and how can we treat them, it's going to be at the nano dimension level that we eventually solve this. Now, I don't know that for a fact, but I'm pretty certain that that's going to be the treatment rather than a chemical. We're going to look back at this in 20 years and think of the chemotherapy that we're doing now is incredibly barbaric, because there are going to be nano solutions to these dreaded diseases that we suffer from today. So I think that the promise is so profound that we cannot look back and say stop. So the advocacy groups that say, don't do anything, I'm not supporting that approach, but I am supporting an advancement that is also, there's oversight to it. And there may be regulatory bodies, and I don't think it's Congress's job to do that. I think it's Congress's job to appoint the appropriate commission that can have oversight over this. And I do believe that this is a forerunner of what is going to be in the future a global cooperation, because nanotechnology is something that's once developed, it's going to be profound, and it's going to have a global effect, not only on the U.S. society, but on the global society. And right now we have a global economy, but we're working on a global community. And I think that this is the promise of nanotechnology, that we're all sharing these solutions, all sharing these wondrous medical advances, these wondrous scientific advances. And it goes beyond the ability to manufacture things. Right now, one of the things that's really promising and exciting about this from a capitalist standpoint is that you can manufacture at a local level, and you can customize it at a local level far more efficiently than you can by building a factory and producing products in the old-fashioned way. So I don't think there's any way that we're going backwards. We're going forwards, and we just want to minimize the harm that we do going forward.
Mhm. Thank you, Professor David Smith. My next question: what are some potential applications of nanotechnology in medicine and healthcare?
Yeah, that's a really great question. And nanotechnology is even hard to estimate the market size and the applications because of where it's today. You see some um, market firms where they begin to say that one Allied Market Research that by 2030 it's supposed to be $33 billion in revenue market size with about 36% compound annual growth rate. You see others like Fortune Business Insights that says last year it was supposed to be around 80 billion, and growing to $248 billion by 2030. And others you see with estimates on all different size of that coin. But if you begin to take those numbers and you talk about their applications and their impacts, in medicine, like we talked about earlier, you see targeted drug delivery, diagnostic tools. You see nanomaterial constructed tiny robots navigating through our bloodstream. You see the consumer products, like I talked about before, uh, with stain resistance, sunscreens with nanoparticles, all types of things, including uh, garments with nanomaterials and sensors embedded into it, doing all types of things in energy, include improved solar cells, more efficient lighting, energy storage, materials, stronger liner materials. I've talked about how they've been used in space and aerospace and construction. Uh, and they're being used even in cars today to begin to build lighter cars to be more efficient but stronger as well and more flexible. Nanomaterials can be very flexible. In electronics, nanomaterials have been used early in electronics because of their properties of conducting electricity, their properties with uh, being very efficient there, and also being able to dissipate heat very rapidly. Heat is one of the biggest problems we have today with scaling, for example, microprocessors and many of the chips. You've heard me talk about environmental solutions with water purification, pollution control, sustainable energy, and many others. And I think I've said this before, Dr. Sharif. What I've seen in figures is there's about 20,000 researchers globally who are working in the field of nanotechnology. That number is going up all the time. And we're seeing increased investment uh, in this area of investment in nanotechnology and its applications. So, for example, researchers have created gene nanochips based on nanotechnology that can switch genes on and off with in a single chip. Uh, and by doing that, you prevent crosstalk and you solve a lot of the other problems there. We're seeing nanoscale sensors and devices that enable continuous monitoring of infrastructure like bridges, tunnels, pavements. And you're seeing nano technology supported transportation infrastructure uh, trying to improve driver safety and communications. And yes, there's a lot of different trends in there. We've talked about some with the materials, the semiconductor nano devices, some of the green nanotechnologies. Uh, nano composites is one that is just growing tremendously fast today because these materials exhibit improved mechanical, thermal, and electrical properties, and that's applicable in many, many, many different industries. Um, we're seeing nano sensors, like I mentioned before. These are some critical roles in personalized medicine, precision medicine, drug development. Uh, and these are tiny sensors that can detect molecules or changes at the nanoscale level, which is a level of fidelity we've never had before. Uh, we're seeing nanofilms come up, which are ultra thin films in areas like coding, sensors, flexible electronics, uh, nano encapsulation, which is using nanomaterial to encapsulate chemicals, to encapsulate drugs, to uh, to be able to protect sensitive compounds together. And we're seeing computational nanotechnology. So these are based on models in intelligent nanoparticle delivery and development that optimize properties and things. So a lot of capabilities there. So, Sharif, I hope that answers your question.
Yes, yes, sure. Thank you. My next questions to Mr. Jimmy. How do researchers utilize nanotechnology to improve energy efficiency and sustainability?
Can you repeat that question, Sharif? I'm sorry.
Yes, how do researchers utilize nanomaterials to improve energy efficiency and sustainability?
Oh, yes. Well, that's a great question. And once again, I want to compliment David for his thorough and profound analysis of the situation, because it is so many applications. And in the research field, for energy in particular, right now we're relying the economy has been moving towards lithium batteries. And lithium batteries have some downsides, recycling them, and the rare earth materials that are required. Nanotechnology allows us to do things far more efficiently, and one of the things that David mentioned was heat. The heat is a problem, and nanotechnology can address that in ways that we have not yet experienced in practical applications. But the future holds is bright in those fields. Just chip manufacturing in general. Right now, in one of the S&P Magnificent Seven companies is NVIDIA. And NVIDIA is one of those companies that is using chips and AI to kind of revolutionize what we're capable of doing in manufacturing. And companies like Taiwan Semiconductor Manufacturing produce these chips, and they have such a hold over. Not a hold necessarily, but they're dominant in their space. But then it becomes a matter of national security, and the Biden administration was wise to pass the CHIP Act, which brings some of that manufacturing back into the United States, because you can't be relying on other countries to send that material to you to use. So the brilliant part about this ability to work on this is it can be done locally, and it can be done in a way that allows the cooperation to occur, and to be shared, but also to be done locally if necessary. And you don't want to. I come from an open source kind of background, so I wouldn't want to hoard it. But you can develop it if it's a question of national security. But the energy um, products that we can develop will be more efficient, less toxic, and less reliant on things like rare earth materials. And these types of advances, the research into them, it has to be cutting edge right now, and they have to be able to, understand production, manufacturing, and quantum mechanics. So it's a big ask, but the research facilities that we have in this world are just tremendous and are well prepared to take on the giant task of trying to understand what we're doing in this field. But the promise for energy and sustainability is great. Right now we've thought of fusion as the only answer. That's not true anymore. We know that we have abilities to create batteries that can be solar powered and self-sustaining in ways that we never imagined. It was science fiction in the past, and it's becoming reality in the present.
Thank you. My next questions to Mr. David Smith. What are the ethical implications of nanotechnology, particularly regarding privacy, environment impact, and social implication?
Well, there's a lot of impact in those different areas, and you see that as you go across the different sides. For example, in the United States, the FDA is trying to regulate nanotechnology under existing authority, particularly looking at the safety of it into it. The approach in the United States is really uh, looking at products and science-based assessment to see if it's safe. And the White House here has put in place principles for nanotechnology oversight. And the Office of the Management and Budget and the Office of Science and Technology are trying to collaborate to develop principles for them. And this is there. In Europe, you're seeing some regulations put in place called the REACH regulation. And REACH stands for registration, evaluation, authorization, and restriction of chemicals, uh, which is looking there. It covers both new and registered substance. And uh, they are putting in place updated dossiers for the chemicals and the nanotechnology and how it's used. You're seeing international standards. There's a group called the National Nanotechnology Initiative that is trying to set global standards in various aspects, including safety, measurements, and how do you even characterize these materials, particularly since at this atomic level field, at the molecular field, it's really hard to keep track of what it's really doing. And there. And, we're seeing them in so many different places that the ethical considerations really have to look at how toxic can these be? What are the environmental impacts? What is responsible development? How do you ensure safe handling of nanomaterials? If I have nanobots going through my blood vessels, uh, how do we begin to understand those and what is there? And Sharif, I think particularly when we go back and look at how this is going to be used in the developing world, you have to see a lot of things there. Because, for example, in India, the Department of Science and Technology is investing $20 million over the next 5 years in their nanomaterial science and technology initiative. We're seeing also in India, the Dubar Research Foundation is spending a lot of money and trying to understand the ethics and the risk of doing phase 1 clinical trials of nanoparticle delivered anti-cancer drugs. If I look at China, PRC, they rank third globally in the terms of nanotechnology patent applications. And uh, we all know that if I look just across the world, there's very different approaches to the ethics. There's very different approaches to the regulatory impacts and safety. And, we see this. And there's also a view of if can nanotechnology ever be equitably distributed across the world? Uh, what is the environmental impact? What is the safety impact? And the international community has to play a role in this. It can't be one country. It has to be a global initiative to assess that because the market for this is global and it has to be treated globally. And those ethical concerns, those safety concerns, the regulatory concerns all have to be handled on a global basis. So I hope that answers, Sharif.
Thank you. My next questions to Mr. James, like, how do scientists address safety concern associated with the use of nano technology and industrial process?
I didn't catch that first part of the questions from you. I'm sorry.
How do scientists address safety concern associated with nanotechnology and industrial process?
Okay. If you don't mind, I would like to ask David's opinion on something that'll lead into my answer to your question. It, we're operating at a level where Brownian motion is a factor, and so how does that limit our ability to understand these reactions that we're trying to pass regulations on, and how does that affect in general? Because my understanding of it is very limited, and I wanted to know your opinion on can we really have a level of precision when we're operating at that level?
Well, that's a great question because if you look at what's happening at this scale, it's not something that I can physically look at easily and understand. And there, so, part of your answer really is uh, how do we how do we understand it? Because these are um, unique engineered materials. They're going to exhibit new shapes, new physical, new chemical properties that we haven't experienced before. And 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 these occupational health risks with the manufacturing using the material really are not fully understood, and they're going to be extremely difficult to understand. And some of the particular areas that I'm concerned about is the things around what happens if you inhale these. Inhaling nanoparticles seems to be a particular significant concern right now because in animal studies, we've seen different inflammation, fibrosis, and even cancer
Yes.
from some of the nanomaterials. Skin contact, ingestion, what happens with that? What happens when we see nanomaterials can cause explosive dust clouds? And how do we look at the different elements on that? We've also seen that nanomaterials, and particularly in vitro application, can move, for example, from the respiratory system into other organs. And we don't understand that mechanism because, again, this is at such a small scale with such unique materials. And there. So in the United States, the National Institute of Occupational Safety and Health has formed now a nanotechnology research center that is trying to begin to address those. But James, I don't know if that answered your question or not, but it's just, we're dealing with a stage of physics and a stage of mechanical science that is of interaction at the quantum level.
Right.
And we all know that interaction at the quantum level is spooky, as people
Yes.
have said before. And it is so spooky that we cannot understand those interactions. And the promise is there. It's one of the areas like artificial intelligence where we're moving so fast that we're well out ahead of regulations
Yes.
and things to do it. And Uh, regulations at some point will probably catch up, but we're at that risky stage where we don't understand it, but yet we're moving ahead very rapidly. So, James, I hope that got answered yours.
Well, yeah, in the sense that what I was thinking about is Brownian motion is at the atomic level and
Right.
can and what it does is make it unpredictable, and that's
It is.
the essence of quantum mechanics is
It is.
you can't predict it. So it's what we're dealing with, and I hope this gets to you, Sharif, is this is where we need the research people to get on. Not that they're not on board; they are on board now, but to get ahead of the manufacturing, the product development. And that, of course, is always going to be lagging behind the applications and the product developments. It's just what the nature of the world. And but the research can be invaluable in helping us understand this because the companies that are manufacturing these things now, producing applications, producing products that we use, that's not their concern. Their concern is the profit motive. Does this make me money? And the answer is yes, it does. And David suggested they're predicting it in tens of billions of dollars, and that's just scratching the surface. So what we need is the academic world to get in front of the commercial world as much as possible in terms of helping us understand what we're doing, because right now we don't.
Thank you. Thank you. Very good discussions. Professor David Smith, what's your closing remarks for today's session?
Yeah, sure. Again, as we've said before, this is a great topic that is there, and it's things that are very important to us as we go forward. There are major opportunities in healthcare and medicine, major opportunities in energy, in environmental, in material engineering. I think the sky's the limit in material engineering as we look forward in electronics and computing. We're seeing nanomaterials helping us even advance quantum computing. as we begin to do it. We're seeing great advances in miniaturization, electronics, and sensors, and consumer products. Uh, One of the advances which I'm thrilled about, but we don't understand enough, is nanomaterials are being now used to produce antibacterial surfaces, uh, which should help slow down the transmittal of diseases. We're seeing it used in sunscreens. I'm going to be over the weekend and early next week on the beach, and I sunburn easy.
Yes.
And I think that will help in biotechnology and nanomedicine. uh, I'm really jazzed about using nanotechnology for genetic modification, for creating small lab on a chip devices that can be miniaturized and used. Uh, and again, even used in vitro as different ways to do drug delivery. Yes, those ethical considerations are there. We've got to ensure the safe handling. We've got to look at the global distribution of this technology, because the fact that this is really manipulated at the quantum level and at the levels where you can't just use your hands and work with it, it's the global distribution, the global disparities are going to be great. And we really have to understand the environmental impacts and the life safety impacts of its use, not just initially, but over time. Because what we're seeing with some of the studies, particularly as we look at its use as building materials in aerospace and outer space, uh, and for underwater, we're seeing that its property changes over time, and that we need to understand its overtime. So I think, Dr. Sharif, that's probably my concluding remarks. It's a great market potential. We see large compound annual growth rates, but again, it is out ahead of regulations, and uh, because of that, there's risk for some early movers that what they do will be regulated out of business. So, Dr. Sharif, I hope that helps.
Thank you. Mr. Jamsit, what's your closing remarks for today?
Well, Dr. Shreve, thank you for having this discussion. I think it not only is it fascinating to me, but it's incredibly important for many for the reasons that David just pointed out. We're ahead of the game in terms of the product development, and like OSHA is a system in the United States to protect the workers. And OSHA is ill-equipped to deal with something like this. And also companies are employing their own scientists in their own laboratories, so they're separate from the academic world. And so, the people that, I think I might have implied that they don't have the knowledge, but the companies actually do have the knowledge at a very powerful level, to manipulate and to produce these products. So they have science on their side. But the bottom line for those corporations is always the profit motive, and it's not necessarily for worker safety, and it's not necessarily for consumer safety. So that's the idea that we need to match up this. So I think the academic world has a great contribution here, potential for great contribution. But the applications that we're talking about when we talk about medicine, this is, I think, the great uh, new frontier that we're working on, because I think the applications will be at a cellular level, and this is going to change everything, the diseases that we suffer from. But as we're talking about, whether or not it's developed countries or whether it's going to be globally distributed. For example, the United States doesn't have to worry about malaria, but malaria is a scourge in other countries. So are we going to put some resources towards uh, curing malaria or treating it in a new and novel way? Where's the motive for that? Where's the profit motive in that? Where is that coming from? So we have to think about being just, and thinking about terms of values as well as profitability when we do enter into this world. And who's going to think about justice? Who's going to think about the applications for the poor? Who's going to think about the disadvantaged? Who, these aren't questions that are easily answered. And I don't know if we're up to the task. The question that I have is that when we advance, in terms of making something worthy of purchase, um, is that going to be one, not doing harm, and two, uh, thinking about the global environment rather than just our own local in profit motive and our own advancement in terms of what's good for this company or that company. How are we going to go forward? It's very uncharted water. Not only are we dealing with materials that are have a lack of precision built into them, so that the understanding of them and the manipulation of them is quite amazing how much we're doing right now, let alone what the future provides. But how are we going to distribute it so that it's fair and equitable and helps the world rather than somebody go up on the Dow or the S&P 500? These are questions that go beyond any one particular company, any one particular country. But I think that the overall the benefits that we can generate are going to outweigh the risks. And I think that that's just idealism on my part, but I also think that that's going to be the way it turns out. We're going to reap so much benefit from this, and we're going to experience some harm. And hopefully we will be able to mitigate the harm and execute and take advantage of the benefits. And thank you so much for this.
Thank you, Mr. James Seed, and thank you, Mr. David Smith, for your continuous support for World Talent Economy Forum. Thank you. Bye bye and take care.
Bye bye.